this work was to a large part done also by Jan, a student of ours who collaborated on this project as part of his master thesis. So let me just quickly mute the room here on my end. Okay, no echo, perfect. The area that we are moving in is this idea of domain-specific replacement, which is a term that we use for anything that you want to put inside of your typically general purpose source code to make it more tailored toward a specific domain. I picked a couple of examples here that are sort of like maybe straddling the line of domain specificness. You have one example like interactive visual syntax down here, which is quite explicitly a certain domain, red black trees in this instance. But then a couple of other ones that are sort of like, if you want to call it a domain, you could, but it's more generally a programming tool where the domain itself is maybe programming. So for instance, you have Babylonian programming, which enhances your, in this case, JavaScript source code using examples that you can attach and probes that are then sort of visualizing runtime values as the code executes. Down here, I got a screenshot of Code Bubbles, which is a project that takes a Java project and makes it navigable in a different manner that is better suited towards discovery and exploration. So the common thread in these projects is that they are integrating with general purpose languages that are not necessarily designed for visuals, maybe with the exception of Racket to a certain extent. And if you have this sort of challenge, you have a GPL, a general purpose language, and you want to put something visual inside of it, the first thing that you have to do is somehow attach to it, right? This idea of we have to find abstract syntax tree structures, match against those that interest us, and then extract the data from those in order to construct our user interface that either enhance or replace the part of the source code that interests us, as you can see in these various examples here, replacing certain parts. The goal, this is what this is the challenge that we're tackling, and the sort of goal that we set ourselves here as part of the design was that we wanted users not to rely on prior knowledge of language internals, such as here you can see this expression in JavaScript, const ocean temp equals array of a couple of values, is composed of this abstract syntax tree here, this certain named connections, etc. And these are all intricacies that a user would have to know in order to build this domain-specific replacement. Specifically, we are thus not targeting non-programmers, but rather programmers that are familiar with their program domain, be that red-black trees or data visualization, etc. Now, I talked about matching and extracting. The idea here is rather simple. Our system, whatever that might exactly be, traverses the entire tree and asks your system, the system that we are presenting as part of this paper, given this as node of the syntax tree, is this a node that you want to have? In that case, return something or else return null. And the something that you are returning should be a dictionary, an object of the extracted values that you then use in order to construct the view that is supposed to appear. So these two functions work in tandem. The output of the one gets fed into the input of the other, the one that constructs the view. Okay, so now we have this idea of we find the nodes in our program, we extract values from them, but how exactly are we going about this? The idea here that we came up with is a query-based system that tries to address the sort of complexities in a sort of a direct or less direct manner. So what I mean by this is, for instance, that we offer users the option to specify essentially the same source code that they're already familiar with. So we had this example, I'm just gonna switch back real quick, of this array here that defines a couple of numbers in this variable. And if this is the structure that we want to match, then we can specify it as such that we just say const placeholder equals another placeholder. So in this instance here, there's no intricate knowledge of the AST required. You literally just type the same source code, right? This is not necessarily a novel idea, of course, but this is an important ingredient as part of the system. The other elements then here that you can chain together in this system then work in tandem to narrow down the elements that you're interested in wherever this query system falls short. So for instance, you can extract fields from the object that you're getting. You can run arbitrary code if you need for instance, compare numbers of things. For instance, we have an example where you construct out of a 2D array a table. And for that purpose, you need to ensure that the rows and columns match. So naturally, that is a piece of code that we would be adding here. And then we have a couple of sort of control flow elements that allow you to specify that you want multiple things to be executed in parallel. And if any of those fail, the entire pipeline fails. Or to have multiple things that could happen, and you just want the first branch to pass through, as well as a form of iteration. So for instance, the same example again, this 2D table. If you want to collect each row again, then you would use one of the looping constructs. So this is the first ingredient, more or less visual matching language that also incorporates code, or in that sense, kind of hybrid. And the second one is live feedback and actions. I brought a screenshot here now of a piece of code that looks for typical declarations of colors. You can see here RGB or hashtag value, and those get replaced by color pickers. This is now a view onto the entire tool. You can see here that the pipeline elements that we saw earlier are also in here. And what you have down here in green is the live values for the first example that you specified going through the pipeline. If there's at any point a failure, it would be marked in red, and you would get an immediate feedback form. Okay, given this example, the current pipeline does not match. This aspect is what enables you to still get deep insights into the AST without necessarily having to have prior knowledge into it. So let's look at a slightly simpler example. We have here an array here, an object with RGB channels. And this is sort of the example input that we're giving it, and that is our pipeline here. How do we get to that pipeline? We first specify the simple query in the same system that I showed you earlier that literally just says, I want an object that has color channels. We can then open this feedback item here. This is an object explorer of the very thing that we just captured, and say, okay, of that object, I want to extract the color channels field. That gives us this extract step here in the color channels. We then need to ensure that all of the values are numbers for this purpose. And we can say simply, okay, the system recognizes this to be an array since it has the runtime data and offers contextually valid actions, which means anything that deals with iteration since we're an array, allowing us to either say we need to ensure something for everything or just we want to run over everything. In this case, we want to match over everything. And thus get this match all suggested here and created. Subsequently, we access the field value of it. Again, we can sort of use this object explorer to drill down, right-click the field that we're interested in, and the system contextually derives what sort of actions are sensible at this point. And in that way, we can just kind of narrow things down until we have this assertion that we want a number type in every single field of the color channels object over here. Exactly. So a couple other things that happened in the paper is that we offer users AST-aware editing primitives. So when you are inside of your view code, that you can transform source code in a way that remains syntactically valid without having to pay attention to every single comma or white space. We offer a couple of built-in UI components for text editing editable code. We have some evaluations, the color picker that you see here, the 2D array that I mentioned, and the tool itself. I'll briefly show you in the tool. This also highlights one of the major limitations. It gets kind of big. So yes, this is definitely not something that you can easily build in the tool itself, which is why we formulated this first and foremost textually and then loaded it into our system. And finally, what we derived as conclusions is that it generally works for the purpose that we specified. However, there are obvious scalability issues. There's still some expertise needed for editing steps, and there's often some mismatches between parse structures, as parsers typically give us, and the kind of structures that users might mean to match. So, for example, you might mean to say, I want a member access, but there might be 3 different ways to say member access in your language, and that creates obvious friction here. All right.
All right, so let's thank the speaker. So we start again with the, what did you see? What did you hear about? I saw a color picker. What did you see? Who wants to go first? Or is it? There's the mic.
Well, first, thank you, Tom, for the presentation. So I understood that in the paper that, for instance, building these domain-specific representations in textual source code is hard. And this is a way of how to leverage that and how to implement these domain-specific representations without having to really know all the underlying host language that you are using to develop this. So that was one of the key messages.
There's a nodding. So
that's good.
Sounds about right. Yeah. So more summary behind you.
So we're doing this. We're phasing the feedback.
You can also ask a question if you want. You can answer it.
So I should just do the summary part.
Criticism comes later.
Yeah.
Yeah.
Should always. Okay. What am I supposed to summarize this and I can't say what I like about it, or can I say what I like about it?
Not yet, but you can keep the mic and I will switch to the next round.
All right.
Okay, one more. What did you see? We see another block-based editor. Maybe what's different comparing with the last talk?
Yeah, so I observed an attempt to try to generalize, to abstract the sorts of operations or development patterns that we see in textual DSLs.
Okay, then let's switch to the second phase. What did you like? What did you wish to see improved? Maybe you have an idea?
Okay. What I really liked was the insight is that ASTs suck. They're really a pain to work with, and there's this sort of dominant ideology that they're theoretically correct and therefore it's the right solution, but I think you've got a really good case here where it's really not that great a solution. They're really complicated and hard to work with, and so I really I love that you're trying sort of to sidestep the complexity here.
Can I say something?
Yeah, you can.
So
go ahead.
What I like about it is that it kind of proposes this end user meta programming idea. So programmers aren't really meta programmers per se, but when do they become one? Well, when they have goals that have to do with meta programming. And then the teaching element or making that simpler, that really I think is not new, but a very appealing idea. And the paper is an enjoyable read, and it presents some ways to take strides towards that. But I do think that there is still a lot of work to really make this fly very far. And of course, lots of people have lots of different backgrounds in different programming languages, and some of the steps just kind of look familiar in different ways, I suppose. And what kind of abstractions one would choose is kind of dependent on what your background and knowledge is. But I found it interesting to see this particular approach. So I enjoyed reading the paper. Thank you.
So we already saw some kind of cluttering in the live demo Tom quickly showed. So what else do you think should be improved in the future? Is it just about visual representations, or is there some cognitive aspects to it?
So what I liked is that the tool very much tries to help the programmer by making these kind of suggestions. What I would like to understand better is in what ways the programmer can still make mistakes, right? Or specifically kind of semantic errors, and in what ways the tool might be able to help, first of all, present the error, and maybe also to help address the issue.
Tom, do you want to comment?
Yeah, thank you. So there's multiple aspects, of course, that could introduce mistakes. One of those I already mentioned, whenever the AST introduces ambiguity, where your intent is to match a large group of patterns that to your mind are the same, but in the AST happen to be different. And for this purpose, the only real solution the tool offers is for you to collect sufficient examples such that the tool can give you the feedback, okay, for these instances it works, but for that one it doesn't, right? Beyond this, if you do a simple programming mistake, such as in this case, you put the wrong regex, the live tooling, the live feedback here will actually give you in an immediate sense that here you made a mistake, and then you just have to drill down in the typical manner to understand what is happening. The nice part is, of course, that you can inspect the objects that the pipeline, that pass through the pipeline here, and understand what the structure is of them, akin to a debugger without having to invoke it in the first place.
Any more comments or ideas on this project? Sure. So we are now in this anything goes last minutes. Yeah.
So I mean, I should also add that I think the paper is really well written and very easy to understand, and I always like to thank an author for doing that. One thing though, you did a sort of like a little survey of grammar query languages, and I think your key idea is to try and use the concrete language syntax, right, as the parsing, as the matching thing. I seem to recall some work in Rascal doing that also. I can't offhand remember what that was, but anyway. So my main question here is your visual syntax with the boxes and the lines and so forth, and I think you even mentioned during this presentation that there's a textual syntax that you can use behind this, right? So a big question here is going to be, well, why not just use that textual syntax instead of these boxes? Is there any real difference in the experience between one and the other? And it's also just nice. That's kind of a controversial thing. It would be nice if you sort of separated that out as a independent dimension here, that a textual, you could still use the textual form of this to do all of this, and some people who may not like visual programming won't be turned off. Okay, and the other thing is, since AST theory is so well developed, right? A question here is just, what is the expressive power, right, compared to that stuff of this language? Is there an easy way to tell us, well, this is easier for easy cases, but there's some hard cases you just can't handle, or can it handle everything? And then that's another thing I'd like to know.
Yeah, very good points. Mm-hmm. So on the first question, why not just use text? Jan and I both extensively use text because the tool is bootstrapped in the sense that it uses itself to match things, right? And the experience is night and day, at least for us. Here you get the live feedback, you immediately realize when things don't work, whereas when you use text, you have this big black box that is also kind of hard to understand because you have this data flow notion where it's kind of difficult to put breakpoints in a manner that you can quickly walk through it. So this is, I think, one of the classical examples where the sort of snapshot that a debugger gives you is just not as helpful, but you need a domain-specific debugger that gives you a sense of the entire progression of the data flow. So I think the lines would not necessarily be a requirement here, but you definitely want to deeply intertwine the feedback mechanism with whatever notation you use in the end, right? So we could very well imagine everything here being text, but this feedback mechanism to still appear on the right-hand side, I think this is the essential part to take away from this work. Concerning the second question, the expressive power, the main product that we based this sort of syntax on is called AST grep, which is focused on these patterns of ASTs here. And they also have a YAML-based syntax because you very quickly run into cases where you want to specify something as like a regex to go deeper into the system. I would like to claim that there's no ceiling to the complexity here, because in the end you can just write code, and that allows you to match any sort of structure. And for all the tools that we have tried, there have been helpful abstractions in here to kind of tame the complexity that comes with just writing code. So I think there is definite promise here, but we still need to make a better effort to exactly specify what aspects of this notation of the query pipeline are the deciding factors for making it easier to work with these complex AST structures.
Mauricio?
Yes, so I was wondering more like as a part of the future work, and I think this is also related to what Jonathan mentioned. So for instance, have you also considered, or are you considering maybe the cognitive load that having this mixed or this hybrid type of editors might have on users?
I have not yet. That is an interesting point. I think the main part that we want to investigate first and foremost is to get rid of these excessive menus. They are an obvious quick way to make these interactions happen, but it makes it very sluggish. One of the reviewers also, I think, wrote that it does not bode well to see all the menus, and I would agree. They're just a very easy way for us to make these interactions possible. So I think a mode that allows you to use both keyboard, or rather to use the keyboard inside of these visual structures, hopefully gets users in this sort of form-filling mindset, which I think people are quite used to from other applications, and thus would not have the sort of dissonance between their mouse and their keyboard that would probably contribute to cognitive load.
Is this something that could benefit from Yoshiki's Greenlight platform? Like having a shared space, thinking about these expressions, working together?
I mean, I would say always and in general. I think this in particular would benefit from the fact that you could probably source a lot more examples if you had more people just typing code into it, formulating the query itself. Certainly if you are in a close communication loop as well.
Any more comments from the audience? One more comment.
So this is perhaps a suggestion related to the last point also about expressivity, is that I think it would be nice to have that this set of patterns that you've captured with these kind of interactions that you provide is open-ended, and that perhaps it would be possible for users to, when they identify their own patterns, or that they identify that they're writing code in a certain way repeatedly, that it would be possible for them to add their own elements to your environment. Is that something that was already considered, perhaps? And of course, then the implementation needs to be extensible in a certain way.
Yeah. One of the major points where we noticed this was actually with Smalltalk. Not sure how familiar you are with the language, but there's typical ways to construct objects. These are three of the very typical means to specify that I want to construct an object. And these are actually completely distinct AST structures. One is a unary message sent. This would be a keyword message sent as the root, and this would be a cascade at the root. But the intent is always the same. So this is one of the things that we instantly, once we encountered this pattern, introduced as users of the system, if you will. But we currently don't have a good way to allow users to visually integrate their own extensions in the sort of visual grammar that we have. So that is certainly something that I haven't thought about yet. Yeah.
Jonathan?
Yeah, I just wanted to I guess, amplify Reamer's comment that I think this is really cool. I mean, it is kind of trying to make metaprogramming for the masses, language metaprogramming for the masses, and I just really like, you know, your attitude of trying to cut through the complexity of the abstractions and make it simple. So great, keep it up. More like to see you continue this.
Let's thank the speaker again.
Thank you all.